getting things going. I'm coming in a little hot, but hopefully it's all working out. We shall see. Looks like YouTube's got it, which means Restream has it. Good. I'm still rearranging my windows a little bit. Like I said, coming in a little hot. I was my whole week's been, well, once I was back in the office, getting into these Yoto Player things, which we'll talk about. So, oh, now I realize you can see what I'm doing. It's all right. Say hello in the chats. We'll get going in just a second. All right. Did I just freeze up? Kind of looks like I froze up, huh? I shouldn't freeze up on OBS. My camera froze. Window cam's going, but my not frozen. My main one I think is frozen. Is that not true? I think I'm partly frozen. Audio is good. That's good. Yeah, audio is not frozen. The Magewell, I think, might be. Unfortunately, let me unplug it. Which is weird because I just logged into my one password and I didn't do it. Okay, I'll plug it into the other end then, I guess. I'll be right back. You can't see me. I could use a different camera if I needed to. Huh. There we go. Now I'm unfrozen, I think. All right, hello David, aka DCD. Thank you in advance for taking time codes. Folks use those on YouTube. You can thank DCD here for, you can thank David for taking time codes during the deep dive here. All right, are we ready to go? I think I'm unfrozen. David says, yes, you are unfrozen. Great. Hello, everybody. My name is Scott. I go by Tannewt online, and I work on CircuitPython for Adafruit. If you don't know what those things are, CircuitPython is a version of Python designed for microcontrollers. Microcontrollers are little tiny computers. They're relatively inexpensive, and you can put them anywhere. You can put them in costumes. You can put them in, oh, you know what? I got to get out my Yoto Mini player. I brought it, I threw it in my backpack to bring it home already. This is a Yoto Mini player. I've put it back together. This has an ESP32 microcontroller in it. It has Wi-Fi access, and now it's running CircuitPython, which is exciting. So I work on CircuitPython. It's it's designed to make it really easy to program these little tiny computers to do whatever you want. And I'm funded by Adafruit. So Adafruit pays me to work on this. Adafruit makes lots of development boards, little PCBs with microcontrollers on them, and they pay me to bring the software, make it easy to program those things. So if you want to support me, you can do that by going to adafruit.com, purchasing hardware there. You can buy from resellers as well, if that's more convenient for you as well. So this is a deep dive. I took some time off at the end of last year because I was watching my youngest kiddo, who's now in daycare. And now I'm back, so I'm doing an hour or so, at least an hour. I used to do 2, I'm only going to do an hour now, but this is a chance for folks to come ask me questions about CircuitPython or software or engineering or whatever. I'll do my best to answer any questions folks have. Otherwise, I just kind of show kind of what I've been working on. I see that somebody dropped in the chat before. I don't even know if they're watching anymore. It was like way before we started, but they said 12-volt power supply for the Pi 5. I don't think so. I think the Pi 5 is actually USB-C, right? So I'm not sure you could do 12-volt. So what we've been covering and has been a big part of the start of the year is CircuitPython 2026, which is our chance to think more broadly and longer term about what we want to do with CircuitPython. So I want to start with that, even though my brain is in Yoto land, or Yoto, I don't even know how they pronounce it. But let me do blog.adafruit.com. I just want to cover this because I want to cover the last few things here. So here's the Adafruit blog. Hello, Yusuf. I should also say we do have a Discord as well. You can join that by going to adafru.it/discord. So I did the CircuitPython 2026 year-end wrap-up here, and yes, I am human. Thank you, Cloudflare. And this is where I gathered all of the ones that we got and linked to them here. So I don't actually remember. I did mine, but these others I don't think I did because I think I talked about mine last week. So let me just queue up these last few that came in and we'll talk them over, and then we'll get on to the Yoto hacking as well. So like I said, CircuitPython 2026 is this kind of annual, longer term, think more broadly about what you want CircuitPython development to look at like this year. And let's see, JG Magnum on the forums posted, I do a lot of low power, often involving solar powered rechargeable batteries and remote projects. Sleep mode is a great tool, but it does not control the sleep state of devices connected to the microcontroller. It'd be very helpful for doing those low power projects to be able to control power consumption of connected, especially I2C devices. That was their goal for this year for CircuitPython. And then folks actually did reply that like there are newer Feather boards that do have I2C or power control over the I2C boards. And they were like, great. And people gave tips on how to actually use that, and they're set. So that's it's an interesting use of CircuitPython yearly, right? Is like, hey, I'd like to do this. And some people can say like, well, you can't do it. It's this way. You know, that's a sign that documentation's not clear, or in this case, they had not quite the right hardware, or the hardware they had didn't have the feature they wanted. But definitely that's a good case. So next up, we had stuff from Foamy Guy. Foamy Guy is Tim. He works for Adafruit on CircuitPython as well. He mostly more does libraries and guides and stuff. So it was interesting to see his perspective on things. He's been doing some local LLM stuff on like Pis, and he's interested in doing RAG, which is retrieval augmented generation. So like, how can you feed in a little bit more information into a local large language model to make it work better without having to be the giant ones? So he talks about that, and then also that for the holidays, he got a over the holidays, he got a MIDI controller and wants to like polish up CircuitPython support. There are some issues with like, if there's a lot of MIDI messages, you can lose some and that sort of thing. And then Tim also did a bunch of display I/O widgets and stuff. FruitJam OS was like, Tim led that effort as well. So he's definitely assuming that he's going to do more of that too. And then today, I actually got these. So last call was on Tuesday. So Wednesday was the last day for people to get these in. Of course, if you're watching this and you say, oh, I would like to get one in, feel free. You can still email circuitpython2026 at adafruit.com, and I can edit that wrap-up post and add more there. So it's not actually too late. It's just kind of like I give people a deadline so they finish. So these are the folks that they got in on the last day, and then I meant to post it on Thursday, but I got sucked into this Yoto hacking. Lamore gave us a deadline. Actually, she wanted us to stop working on it on Wednesday, but I was like, no, give me the end of the week and see how far I can get. So I'm rushing to polish things up for getting a PR out by the end of the week and like kind of moving my brain off of it. So I didn't actually post this until this morning. That's my point. I like didn't let myself get into the Yoto stuff until after I did the post and the wrap up. So John posted a lot of really good stuff. I was impressed by this, talking about it. And so I'll just quickly go over it. OTA, so this is over the air and updating the CircuitPython firmware itself. I've actually the last 24 hours, I've really wanted this because of this. It has an ESP32 in it, but there's no pins to get to it. And you have to like crack the back off and like touch some UART pads and stuff to flash it. So it would be great to have OTA support. So I agree. I think that would be cool. I don't know how we want to do it, but they have some ideas, and I agree that like especially for these cases, it's like it's such a pain otherwise. John also suggests Thread and Zigbee. Zigbee's not on my radar as much, especially because Zephyr currently doesn't have Zigbee support. My CircuitPython 2026, which I talked about last week, and my 25 actually was all about Zephyr support. So like not duplicating efforts for new ports, because Zephyr has an abstraction layer on top of things. So for something that's networky like that, like a Thread or Zigbee, it's like definitely in the camp of like I'd really prefer to do it once and then be done with it. So I think that Thread will definitely come because we do want to get back to circuitmatter and be able to do it over a lower power than Wi-Fi. But I don't know about Zigbee. I don't think there's a Zigbee API in Zephyr, so there's not something we could target kind of uniformly yet. So Thread probably, Zigbee, I don't know if we'll get to Zigbee this year. Web workflow over Ethernet is definitely something I've been thinking about as well. Ethernet support we don't actually have in the core, but Zephyr has Ethernet support. So, and I can't imagine it's that complicated to hook up. I just haven't hooked it up yet. But I would love to support Ethernet natively. They do mention the ESP32P4, which Zephyr does not support yet. The IDF is like pretty good, and so I kind of imagine that like we'll probably do it in both places, Ethernet, just because it shouldn't be too bad. And once you have sockets, like web workflow should be pretty easy to do. What about Matter? Well, I talked about this a little bit, but yeah, I do want to get CircuitMatter properly running in CircuitPython. I believe most of that work is providing like cryptography APIs into CLAN so that it's not all implemented in Python, because that's really slow. But yeah, we definitely want to do Matter. I bought some of the new IKEA Matter devices to interface with, and I was actually thinking about for the Yoto Player, there is actually a standard for casting two devices over Matter. I don't know how widespread support is for it. I hope that it's going to increase, but being able to use Matter to like control what's playing on a device would be cool too. All right. Next up, John said a web-based build system. I think you can actually do this. Somebody committed using GitHub runners, I think you can actually do this already. We're definitely wedded to GitHub. I know some people are moving, but we get so much free CPU time to build like all the boards in our CI. Like, it makes us, we're not gonna, it saves us thousands of dollars to be on GitHub. And another reason is that like you could do these custom board builds, which I think you can. I meant to look it up and I didn't do that. But I'm pretty sure we actually do all have this, and I don't think Adafruit's ever going to host it, but yeah, like we have pretty good building docs, so people could do it locally if they really want to. So yeah, I don't think we're going to have a self-service sort of thing, but if we can make building easier, that would be good. Better LLM-based code generation. This is very interesting and something I tried to talk about as well. Really figuring out how to harness these coding language models into generating CircuitPython code and getting a feedback loop going where you can like see the serial output, but potentially, I was thinking about this last night as I was doing like this has a display, having a way to feedback like the image that's being rendered to the display, because the models can actually take images in as well. Being able to do that, I think, is really, really interesting, especially because I was like, I want to add this feature to like switch albums, and I don't have it yet, and I'd like to add it. So I'll show you more of that later. I know I'm getting distracted. But yes, I think that's definitely part of it. John points to Circ remote, which I have to look up, but that would be cool. I think it's just remotely accessing CircuitPython stuff over like web workflow or things. Next up, Dan posted async support for networking. I think this makes total sense. I don't know how much of it's going to come. To me, it's still a like Zephyr dependent thing. Like most of what I want to do is Zephyr dependent. Although, as Dan points out in his second bullet point about preemptive RTOS, like the expressive ESP IDF uses free RTOS, and Zephyr support. You can see here, this link here is Zephyr support. I don't think they've updated it. It's still updated from August, but like last I saw, Zephyr was trying to like, you can see they have kind of like checklist of what's supported in Espressive's version of Zephyr, or Zephyr that they've worked on. So I really would like to see Espressive start using, so like getting support for Zephyr equal to the IDF, which it probably never will be, because IDF is the first thing they look at. But I'd love to run it on the P4, especially because the P4 is dual core. So yeah, I agree with that. Updating the getting started documentation. I think we do need to do that. I agree with Dan. I don't think I'm going to be the one to do that. But moving off Mu would be a good thing, because it's like pretty clear on its website that it's deprecated. And then testing it. Dan says, we don't have test suites for networking or external interfacing like I2C or PWM, and writing the test can be tedious, but LLMs can help us do that. This is something I'm interested in, especially within the context of Zephyr. I'm in Zephyr land, but Zephyr, testing is very much a part of their culture, the Zephyr development culture, and so I think there's a lot we can build on top of. So for example, they have I2C like stubs basically that you can build out. You can build a native simulator board. So I might actually do that next week, because they also have, they call it BabelSim, but the Nordic folks use it for testing BLE off device. So there's like BabelSim versions of Zephyr boards that mimic Nordic boards, so that you can do BLE testing without having to do actual devices, which, as somebody who's about to do BLE, I think would be really helpful. And the other thing is that I'm listening to a lot of stuff about how to code with LLMs because I think it is really a huge deal. And this is what my CircuitPython 2026 was about last week. But part of the key, I think, that I hear and understand to getting LLMs to really work well for you is to have a really good feedback loop. So like tests that the LLM can run, right? Or talking about how to do CircuitPython programs, like being able to like see the display output, for example. Like those are all really interesting and kind of critical to letting an LLM iterate on its own. So tests, I think I agree, and I'm hoping that we can at least do it through the Zephyr port and inherit some of that stuff. And then Blake points out like it'd be great if CircuitPython was preloaded, and Dan kind of points out that like actually we did that briefly and we kind of don't want to anymore because the longer stock sits at the warehouse or at the shop, like the older CircuitPython gets, and we tend to move pretty quick. So if the first thing we're going to tell people to do when they get a device is to like flash CircuitPython on it because we want them to have the latest, like it doesn't really matter if we flash it first off. This is something I was like pretty insistent on up front, but like it really did matter. It really was a support burden of like, we ship with CircuitPython on it, but by the time you get it, it's like a year out, right? It's a year old and we found bugs or something like it. So you don't want to have to like make something, flash it, put CircuitPython on it, and then for every CircuitPython release, like update it. You don't want to do that. So yeah, that's the reasoning behind why we actually don't see more stuff shipping with CircuitPython. And then the last person was Steve here, who I've not, I don't know if I've interacted with before, but did a really, really nice post. I love this. This image is pilfered from Adafruit. Sorry, I just wanted something here. That is okay. I think technically it's a Creative Commons license one anyway. It doesn't matter. You're using it within the right context. So it's interesting that they start with a how I got here. Is like, I'm not a Python person. I like JavaScript. Espruino was awesome, but for hardware I've moved on. Like Espruino is like only very limited. They don't build for the hundreds of boards that we have. They went back to Arduino and Platform IO, but that was no fun. Oh yeah, and they wanted I2S audio, and it wasn't possible with Arduino or Platform IO. So chose CircuitPython, love Adafruit, don't want to have to do all the serial cable stuff. Exposing the file system is great. I can take a piece of my homebrew hardware somewhere, and if it plays up a borrowed computer is enough to make the changes on the spot. Totally. A friend can easily drag and drop new samples on it. Yeah, and that's definitely one thing we've been focused on. So reading this top part was like, it was nice. It was really nice for me. Like sometimes you lose sight of like everything that you've done well and kind of what you're going for. So that was really awesome. So thank you for that, Steve. And then Steve points out that, okay, what can we do better? One is WebDAV. And this like kind of came up to me at the time. And so WebDAV is this like protocol for doing file operations over HTTP. So you have like I'm using KDE, so I could use Dolphin to connect to a WebDAV server. And this is the sort of thing that I think an LLM would do quite well. Because it's like WebDAV has a spec, and there is like already like the web workflow HTTP server kind of structure that it could copy. So I don't think LLMs would be too bad at implementing this. But testing is still tricky. And so I think that Dexter points out they got ChatGPT to run the Unix build of CircuitPython in a sandbox. Nice. Yeah, we definitely do a lot of tests with the Unix build, but I'm curious about the Zephyr stuff because it's going to be a little bit more like mimicking how things look to more code, I guess. So I definitely want to try it next week, especially for getting the BLE stuff. Like, I'd love to add BLE tests, like, and then we could actually have BLE workflow tests. And I'd love to do, like, I was looking at how the native sim for Zephyr does networking. So, like, figuring out how to do, like, you could do then web workflow tests and, like, all this stuff. There's, like, their USB device support has USB IP support, which is, like, some crazy way to, like, share USB devices over TCP IP. But that means that, like, your simulator can kind of like get plugged into the hosts, like, all virtually. And I was just thinking today, I was like, oh, I don't really want to plug into my host, but I would love to have like a version of PyUSB that was backed by USB IP, that sort of thing. So it's definitely something I'm thinking a lot about. And I think, and I said this in my post, and I'm still thinking about it, is like really getting our testing game better, and would be really huge. And doing it on using a simulator would be good, because that means that you can test it in CI. But now, since I'm talking about testing, I also did order octo probe tentacles. So this is a project that somebody has been doing primarily for MicroPython. But these are these like harness boards where you solder a test board to this surface area and do like jumper wires into it so that you can like program and flash a test board. And then there's a 40-pin connector to send it off to another one. I've got 5 of these. So the idea is that you have like 5 different microcontroller boards kind of all hooked up and wired up so that you can automatically flash them and run tests on them. So I did get those. Hardware in the loop testing is always an ideal, but it gets really tricky, especially when you're doing networking or USB. Like, the first year I worked on CircuitPython, I tried to set this up and I ended up like crashing the Linux USB stack, and like keeping it running was a huge pain. So I still think I want to start with the like, how do I get it working with a simulator? Because if I could take that far, like that's the most universal. Woo. But eventually on the device would be good too. All right, that was a distraction. WebDAV, I think, would be better if we already had tests that did networking. Steve said VGA composite video. I will tell you right now, I do not care about composite video or VGA. I'm just like, my goal with video output has always been like plugging it into modern things. I don't think a lot of people have like VGA and composite still. But they also point out that like, hey, if anybody could get outputting images through the DVI HDMI port on this board, like, that'd be cool. And I'm like, I emailed the Mac. I was like, I could help you with that. Like, it should be easy. It should be easy to get Pico DVI going. They're in the UK, so they talk about some challenges getting the Fruit Jam in the UK. Then they talk about a VS Code extension, and the fact that it's kind of like supported, not supported, supported, not supported. They say, I'd love for Adafruit to support it, and I'll tell you right now, I don't think it's going to happen. I've never been a VS Code user. Nobody here is really a VS Code user, and frankly, I don't think VS Code's the future. I'm much more interested in doing this like Claude Code sort of setup. I think that is like one thing we try to do with CircuitPython is meet beginners where they are, right? And like, beginners are not going to start in VS Code anymore. They're going to start with an agent, a coding agent, and you know, there's this like, is vibe coding great or not? But like the idea that you can like write CircuitPython code, see if the device does what you want, and then just like use it if it does, like that is extremely powerful. So like that's what's interesting to me. I don't think that, and like there's work there to do of like engineering to connect the pieces together to get good results. But like a plugin for VS Code is just like not. I just not a fan of VS Code. It's too noisy. Zed is a bit of that as well. But yeah. So hopefully somebody will support it, but I don't think it's going to be Adafruit. And then they talk about their synth stuff, which is kind of like mostly what they're working on. I think generally synth stuff is still going to be a thing for us this year, which is going to be great. I'm very excited for, you've seen a theme, very excited for Zephyr to be able to properly like multi-thread, multitask with audio stuff, so that you can like have some thread that's filling your audio buffer and you don't have to like, in CircuitPython right now we have this rudimentary like background task system, but it's quite ugly. I'd much rather have a proper RTOS to manage it. So that is CircuitPython 2026. I think those are all the ones from last deep dive to now. So you can go back to the last few and take a look at that. You can also look at this blog post if you want to read up on them on your own. And as always, we're happy to hear what people want to do and particularly help people get other stuff done that they're wanting to do. Are there any questions about that before I move on? Actually, I'm hoping I can get to do a little Claude before we're done. All right. I don't see any questions. The chat's pretty quiet. So let's talk Yoto. So Yoto is... are these devices for kids. There's a small one and a big one. I don't think it's plugged in. I think I could grab it. This is why I was running late. I was trying to put the big one back together all the way. I haven't fully put it all the way back together. The big one has this grid of LEDs in the front, and they advertise it as screen free, which I think is funny. Let's see, where is it? Where did I see it here? Yoto Player, Yoto Mini. And then they sell these cards. So they don't have the screen 3 advertisement here. But this screen here on the Mini is actually a screen. And this is what took me so long to figure out. Because if you Google like 1.3 inch 240 by 240 display, it assumes that every one of them is an ST7789. And it turns out this one is not. So it took me a long time. Like I was like having a challenge of getting the display working because there's some pins that like the chip select line and the data command line are on the IO expander because they don't have enough pins to do it from the ESP32 straight. And chip select is a great thing to put there because you do it once, you send a bunch of data, and then you turn it off, and it's not too slow. So I had to add all that support, and that's what the pull request is going to be about. But then figuring out actually like what device it was like not easy. I was like doing lots of Salier captures, and I finally it's like, oh, you know what, like it's weird that it's writing these registers because like they're not documented on the 7789 at all. And I like found like one or two chips that like kind of had it, and then I was like, you know what, let me look in the firmware. I have firmware dumps for both this and the big one. I didn't look at the big one at all. But let me look for it and just look through the strings, and sure enough, I searched for GC, which is a manufacturer of chips that control displays like this, and I find a GC9306. I'm like, oh, okay, that's what the display is. And then, since I'm talking about this, I ended up figuring out that actually the firmware has JSON data files that include the entire pinout of the device. It's awesome, and I'll show you in just a bit. But let me show you what I've got working. And I actually was wanting to plug it in. I'm not sure how far it'll reach, but I should be able to actually capture music off of it. But it's going to start up on a song I don't want to play. So I'm holding the gray button on the side. There's some power circuitry that I just don't fully understand. But I don't know if you can see it at all. But it's loaded CircuitPython. There's the CircuitPython stuff, and now it should be loading a... I turned the brightness down. That's the problem. You can't see it. That's a bummer. You know what I could do? So if you have a device like this, you can do CircuitPython. If you put your hands on the right keys, you can do circuitpython.local, and it will just, I'm on the same network as the device. And so it found my Yoto Mini. I can do /code, and I can connect to it. It works really well here, and it doesn't work very well at home, and I'm not sure why. But I can open code.py, and then this is where I set the brightness down, and I'm just gonna hit save, and now we can see the output. So this is running on this device. You can see it's restarting, my brightness is higher, and now you can see the album art. This is a local band here in Seattle called Smoky Brights. I don't want to like try to get copy protected or copyright striked. So I'm just gonna, so I made the knobs. Let's see which way I want to go. Hey. So this is going through all of the tracks on the album. And then now this is the Bartle beats. So I know I can use this. So now I'm going to plug it in, and hopefully it's not going to be too loud. I guess it's turned down here. So I don't, hold on, let me put my headphones on so I can hear if you can hear it. So I didn't get the speaker working. Yeah, it's quiet. Can you hear that? It's playing from the... So I think you can hear it now. So now I can, so I have the album art showing, and then I can turn this to, turn the volume up, and then I can turn this to switch song. So this is great because we have like kid headphones for my 3-year-old, and yesterday he was plugging his headphones in and he could jam out to like his own things. And then loading files you can use, I'll show you. So we're wirelessly connected. Volume down through the Yoto. So if we just go back to circuitpython.local, one thing I just changed today that'll be in this PR is I made it cache static resources, because I was like watching how badly it was working at my house, and I was like, why in the world is it fetching the fave icon every time? Like, it makes no sense. Let's just cache it. And so I figured out how to set cache headers for some of the static stuff like that. And so hopefully web workflow will work better after that, and I'll have to try it at home later. In fact, I've got to change my settings.toml. I wonder if your house is less happy due to the MDNS compatibility and router mesh. Yeah, it's a ubiquity network, and I wonder, I tried it using the IP, and it shouldn't have a problem with MDNS then. But yeah, this is why I'd like to get testing. So what you can do is you can, so this /SD is actually the MMC. So there's a 32 gig MMC in this device. And these are actually all of the files that come preloaded. And they're actually, they're not MP3s, they're AACs. So we can't play them yet. But they're all on the device here. I don't know what those other things are. They're just like totally obscured. But then you can actually, so cards, I forget what cards is. So I'm browsing it over the Wi-Fi. Here's the Bartlebeats. So the way that you do it is you put all your MP3s in a folder, and then you can have a cover.bmp. So that's what gets shown on the screen, and I scale it down. I use on-disk bitmap, but it's just 240 by 240. So yeah, you can use this to upload. So at the bottom here, you can, if you select this uploads a single file. If you use this, it can upload the whole folder for you, which is great. And then there's disk usage here, so 6.2 gigs out of the 31. It's 32 plus overhead. So that's the Yoto, the Mini. What I was gonna do is I have one of the big ones as well. And I want to make a board def for it. So it's not going to all be working. I do want to move off it like when more asked me to. But I do want to make a Yoto Player version and flash it here so I can hack on it. I think I've gotten most of what I need from having it all torn apart. So as long as you don't have to tear a ton of stuff apart to get access to the UART lines where you can flash it from. So I've tried to put it back at least to that state. So what I was going to do is in my Yoto branch here, let me take my headphones off. Oh, and because I haven't figured out the power stuff, I'm actually going to turn this off too. I'm going to turn the volume down here, and then the gray button, there's a gray button on the side. I haven't gotten the speaker working. If somebody is interested enough to get one and hack it, it'd be great to get the speakers working. I don't think it's too hard. It's just I'm out of time. And frankly, with kids, it's okay if the speaker doesn't work. Because then they can, play songs really loud or whatever. So this gray button on the side here, it kind of doesn't really look like a button, but you hold it. And it's got some power circuitry I don't understand. That if you hold it long enough, it will turn off. It's like 10 seconds, but so you can turn it off and on. I think it's like quite off. I haven't run out of batteries yet. I don't do any battery monitoring, although there is stuff there. So yeah, if you have kids or want a portable speaker that's a little chunky that you can put CircuitPython on it, these are like $80, and then the big ones are 110. The 110, I'm excited to hear the sound quality. I was shocked, actually, talking about sound quality. The MP3s I'm playing, like the Smoky Brights and the Bartlebeats, are straight off of Bandcamp. So I just downloaded. Bandcamp has MP3 V0s. I didn't have to do any sort of Audacity stuff to knock down bit rates or things. I just took them straight off Bandcamp and they play, which I was quite surprised. If you're doing web workflow, it hitches. But generally you're not going to be. You're just going to be listening to music and it plays just fine. It was awesome. So kudos to Jeff, who I think did a lot of the MP3 work. And then I actually did buy, so my 3-year-old loves this song called Here Comes the Fire Truck. And he requested it be on here. So I was like, I don't know how to buy MP3s. But I figured out that on Amazon, I can buy an MP3 of this thing. I don't think they're on Bandcamp. I know how to buy MP3s off Bandcamp, but I don't know, if I wanted a Taylor Swift song, where would I get an MP3? I don't know. Because it's like a Spotify streaming world. But on Amazon, if you go in details and you're on the desktop, you can $1.29. I bought a single MP3 of Here Comes the Fire Truck. So my 3-year-old's gonna be happy. That's why I have to bring it home so that he can listen to it. But I do want to at least get a board definition for the Yoto Mini going, and I thought I would claude it up. So if we look at what I've got, so I mentioned the fact that there's these JSON files in the firmware, and I've ripped them out, and I had Claude format them. So this is from the firmware. I'm not going to distribute these because I think they're, I don't know. I'm not sure I should. But if you happen to have a firmware dump, you can grab these anyway. For their different revisions, so the thing here is the memory address, and then I've like noted which revision it is. And then they have this like thing, okay, battery monitor, this pin is this IO expander pin 6, port 0, pin 6. This is what kind it is. Oh, USB controller, it's this, and then here's these pins for that. Qi charger, so the big one has a Qi charger on the bottom for wireless charging. They sell a separate dock that's Qi compatible. Here's the particular controller IC. I was like, this is awesome. Like, I think this is a great example of the sweet spot, I think, for repairability, right? Or like repurposability is like, I didn't have anything to do, like I didn't have to do anything funny to like get my own firmware on there. I don't have interest in like reverse engineering their files or their APIs or anything. Like I'm just want to put my own firmware on their piece of hardware, and this as a reference is awesome. It's awesome to be, okay, here's the pins. So like the power button is on this pin, and the encoders are this one, and the push button is this, and oh, you have to reverse it. There's a nightlight functionality, which I still don't know where it is, but it's like an RGB controller thing where you can actually also pipe in audio to it to like presumably respond to the audio or synchronize with the audio. The light sensor, what the pinout is, there's an ADC on this one, which I haven't even explored. What pin is the headphone expander on? Where is the I2S pins? What are the I2C addresses of the different like DAC chips? The SPI lines, I2C lines, the like IO expanders, and like default settings for them. SD card, what kind of display it is. So like this is the V3, the big one, which is like the LED grid, and then they have these like constant current LED driver chips, which is this one, which I want to poke at. If we look at the Mini, so this is the Mini pinout, we can see that it's got this GC9306. So that's the like display controller. I found these yesterday, and I was like, this is exactly what I need. NFC, UART lines, accelerometer. So this has like a nightlight mode where you turn the like, it's got this 16 by 16 grid of LEDs, and if you turn it facing down, there's LEDs on the top, and it goes into nightlight mode. And it's based on this tilt sensor. It made it tricky to like I have a couple I2C captures of like starting up, and like I2C and SPI lines in particular for like reference later, before I put it all back together. And it was like tricky because I couldn't have the board face down with the ESP up. I had to like tilt it enough that it didn't trigger the tilt sensor because I wanted to get captures of like it filling out the LEDs for all of the displays and stuff. So interesting. It's been a really fun project, and I hope to get to the point where I can use both of these devices with my kids. The minis I think are the way to go, like if you wanted to try just one, just because they have the screen that's nicer. Oh, Tyeth says, I think my nieces have an older one. I have to persuade them to part with it. If they grow out of it, then yeah. I probably won't support the older versions, but these JSON blobs are exactly what you would need to know the pinout. Like this one here is like, doesn't say what version it is. So it's probably an older one. Like, look, Nightlight type MCU. It's still got headphone types, but it's got like a different, it's got one speaker thing instead of two. Oh, that explains the PA control. I wonder what this chip does. Okay. Let's just take a look. It's so useful. Oh. So my paste buffers are messed up. ES8388. It came out with the right. I accidentally pasted the YouTube ID. Looks like the one on the P4 boards. Ah. We were doing this all by like trying to figure out the chip based on looking at it. And then I find this JSON file and I'm like, oh my gosh. Like, you don't have to do any like beeping out or anything. It's such a great reference. Like, I don't, it's the thing I care about most. I just wanted to see. So there's a mux. Left in 1, left in 2. Clock. I was just gonna see what the PA control thing is. I thought there might be a PA control to say whether it's going out the speaker or audio left, right. Maybe not. Line or headphone. No, it doesn't. I was just like thinking about getting the speaker working. I don't know. Okay. So what I wanted to do is, and I'll give you an example. So the other thing I like to use when I'm doing Claude. Okay, we've only got 5 minutes, so I'll probably go over a little bit. But if folks have final questions, let me know. So my favorite tool for Claude is to look at my Sublime merge. So we can see here that I've got like this Yoto Player v3. And all I've done is I've copied it over. So I want to say update boards.yoto Player v3. I don't know why I did ... Right now, it is a copy of boards Yoto Mini 2024, but the functionality isn't quite the same. Update the pinout based on, it should be able to pull in the 0x for the mini, and I don't know why it's doing for the player. Also include pinout names for. So I know the older versions had SD cards. V3 version. So I'm just going to give this a try. If I had put any work into those files I'm asking it to modify, I would do a git commit. But because it's simply just a copy, I don't need to do that yet. So let's see what it does. I don't know why the dot dot dots are there. So this is Claude code. It's saying like, hey, are you allowing me to list that? I don't know why it's dot dot dot, but it figured it out. It figured it out anyway. That like that wasn't the right path. Or no, it found the player, but it didn't find the mini. I don't know, that their tab completion's wrong. But look, it's saying like, let me just do this. Famous last words of the RMRS the world. I did start Claude in the Espresso folder. That should be fine for this task, but generally it is better to do it at CircuitPython at the top level. Largely because if I'm using it for stubbing out APIs, it wants to look in shared bindings and shared module and other ports. But in this case, where I'm just asking it to reference stuff in this directory, then I'll do that. So it says now update the Yoto Player files based on the JSON pinout. V3 Player has significant differences from the Mini, including different encoders, single line SD card, and display type. I don't think that's true, but we'll try it. 2613, that looks right. Temp sensor. And I could just tell it to do everything, but I don't think I will. I think I'll wait. Let's see. All right, DCDs. I won't do any other topics, DCD. They're gonna have to drop out. Okay, so here, yep, they're adding spy pins. That should use display underscore as well. So I have this hooked up. So like, Laura is definitely pro using LLMs. So this is she's paid for it. It's on the Adafruit account. If you're curious. Okay, sure. Oh yeah, look, and it has displays CS0 through 3. Yes. But it doesn't, like, it's important for people to realize that this is just saving me typing. It doesn't have to be perfect. It just has to, we're at 3 o'clock. Let's do the allow all edits. So I don't have to approve each one. Because I can, like, I could diff it, or I could just review it. Like, I'm going to test it anyway. So now it's updating board.c. I think that it should figure it out. So this is a case where it actually needs to create 2 IO expanders. Actually, I'll escape it. IO expanders. Not one with 64 pins. 2 separate 16 pin. Any other questions before we wrap up? I mean, this is pretty much what I'm going to do, and then I'm going to try to load it, but I don't have a great setup to show me loading it. But this is kind of like me talking about using Claude, is that it's like a really good first pass, and it saves a lot of like the manual stuff. Like I didn't even need to do the it didn't do it. It still didn't do it right. 2 IO expander objects. Let's see. I love it. You're absolutely right. Let me update it. So silly. Silly but fun. Let's see what it does this time. I think this is like coding now. Like there's a reason people are like, I do multiple things at once. It's because you're just sitting here waiting for it to do it. All right. So it generated more. Did it make 2? Yes. It has an IO expander 0 and IO expander 1 now. It is only setting IO expander 0 in board, so that's not ideal. But it did manage to split the 2 appropriately, I think. Which is great. Like, I'll still test it. I don't know about this stuff. I will have to look. And look, it deleted all my display stuff, which is correct. SD cards. I don't think it's 1 pin. Is that true? I thought it was still 4. If we look at SD. Oh, yeah. Oh, no, the old one. Is it significantly different between? Okay, SD1. The V3 is an SD1 as well. Okay. So it got that right. Interesting. Okay, well, it's done. And it says it took 2 minutes. What we can do is we could say cost and see that it costs 76 cents. I wonder how much I make per minute. I don't know. I should do that math. Actually, I can do that math. Yeah, that's just wild. I make more than that cost. If it was 76 cents for 2 minutes, it costs more for me to sit here and wait for it, which is why it's a great tool. Okay, so I'm going to get to testing this and see how far I get before I make this pull request. Yeah, you should see a pull request. If you want to follow along, I have the Yoto branch. If you ever want to see what I'm working on, you can go to GitHub, Tannewt, CircuitPython. The way to do it is to go hit this branches thing. I have way too many because I never delete them. But if you hit branches, you can see your branches, and it includes the ones that I've pushed to most recent. Remove never reset is something I really want to do, but I haven't been able to test. So this is another case where, like, if we had better automated testing, I could have more confidence that that would work out of the box. Audio bus IO, I'm still kind of like waffling on for Zephyr. And then the Yoto branch. Is there learning resources for CircuitPython? You came under the thing. Yes. The place to start, there's 2 places to start. So learn.adafruit.com. And then if you do, there's one called Welcome to CircuitPython. So that's this one. This has all of the, like, how do I get started? Like, what is this drive thing? What editor do you want? And this is what Dan said should be updated, but it should still get you going. And then it has a link to CircuitPython Essentials. So once you get CircuitPython downloaded, installed, and going, you can go to the CircuitPython Essentials. And I actually landed here. Oh, it's going to kick me. It hasn't kicked me to the guide yet. But it's a great resource for, like, oh, I want to do PWM or servos or neopixels or dot stars. This is like kind of a great jumping off point. I used it for MP3 audio. And it has a demo, and it says, like, hey, like, mono and stereo files from this to this. I think mine are more like 200 kilobits per second, and they're working okay, at least on the Mini. So that's interesting that the Mini has 4-line SD cards, whereas the big one only has 1. So I'd be curious if it can't keep up. But yeah, so those are the two places. Learn.adafruit.com. There's a lot of resources there. And the sirens are on my end if you can hear them. And then welcome to CircuitPython and the CircuitPython Essentials are the two places to start. The other thing Dan pointed out is Prof G CircuitPython. Build with Prof G teaches CircuitPython at a university and has lots of good CircuitPython school playlists and stuff. So that's the third resource that we need to link to here at some point. All right. So thank you all. This has been another deep dive with Scott. Thanks to DCD for doing time codes as always. Thank you to Tim, who usually fills in for me if I'm unable to do it. Hopefully this stuff is interesting. If anybody picks up a Yoto Player, let me know. I would love to get more working. In fact, like part of the reason that I can put them all back together is that I can bring them home and hack on them at night if I really want to. Since my kids will probably use it. And yeah, if you want to support me, you can go to adafruit.com, purchase hardware there that runs CircuitPython. You can go to the Discord server, which is at the URL adafru.it/discord. I'm there all week while I work. And there's folks always around there that are happy to help. So thanks a lot. Have a great weekend. I'll show the camera. It's a nice sunny day here. And then we will be off. Nice, kind of cold and sunny day here in Seattle. Have a great one, everybody. I will see you next